Hey, math students. We have a student in a GED group that I belong to who is actually studying for a different test, her HiSET test. So don't panic if you're taking your GED. This isn't on the GED, but apparently it is on the HiSET. So let's work through it here. It says, a girl is looking at a bird as shown. How high is the bird flying? Now, in the original problem, they had a multiple choice answers. I'm just going to do this by hand here. But the first thing I want to point out to you is notice the shapes we see in the diagram. You see my really crappy drawing. I'm not an artist, but we've got this girl here. She should have long hair, huh? And what you notice is that with her eyes, if we look straight across, and then we go straight up to our very ugly bird here, and we look at the angle at which she's looking at the bird, it actually forms a right triangle. And you know that that's a right triangle because of that little right angle there. Now, a lot of us are used to using the Pythagorean Theorem whenever we see a right triangle. We see a right triangle, we want to know missing side, and we bust out the Pythagorean Theorem. But unfortunately, on this particular problem, we don't have enough information to use the Pythagorean theorem. And I'm sorry, I realized I just forgot a measurement from the diagram. Let me put it in down there. But we don't have enough information to use the Pythagorean theorem. Reason why is because we only know one of the sides. If I look at this right triangle up here, I know that since we have a couple of right angles going, if her feet are 25 feet from underneath the bird, then so is her head. So this is 25 feet. But I couldn't use the Pythagorean theorem because I only know one side of the right triangle. I need to know information about two sides of a right triangle in order to use the Pythagorean theorem to solve. So I feel a little stuck unless I know my trig ratios. There's three super important ratios that we use in trigonometry that help us to find missing sides of a right triangle. And you use them when you know a side and an angle. And so this is the new bit of information when we have an angle. So here's the three super important ratios you're supposed to know. You are supposed to know the sine of an angle theta, and I use theta just like I would use x, okay? It just means an unknown angle. The sine of theta is equal to opposite over hypotenuse. I suppose I should spell it out, especially if this is the first time this is going into your notes. Okay, the next ratio you're supposed to know is the cosine one. Cosine of any angle theta, again, theta is just like x, okay, some angle, is equal to, let's see, adjacent over hypotenuse. And the last relationship we're supposed to know is the tangent. Tangent of theta is equal to opposite over adjacent. And if you're thinking, dear goodness, Kate, how am I supposed to remember all this? A lot of teachers joke around or abbreviate this SOHCAHTOA. They talk about an Indian princess, SOHCAHTOA, to help you guys remember these three important ratios to know. SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. Use that abbreviation like the rest of us mathematicians to remember the three, and you shouldn't mix them up too much. But now let's talk about what they mean. Basically, what mathematicians did is they realized that there's a really super important relationship. If you know one of the angles of a triangle, then you actually know the relationship or ratio between its sides. So any two sides. And so we've got three sides. So let's just mark an angle with a theta. It doesn't really matter which one I mark. So I'll call this one down here theta, okay? So now I'll have three sides on this triangle. The one across from the right angle is always the hypotenuse. That's called the hypotenuse of a right triangle. And now to talk about opposite and adjacent, I'm talking about opposite and adjacent sides in relationship to this angle down here. So if the angle is here, the side that's opposite that angle is across from that angle. And then adjacent is actually, connected to this one. So here's my adjacent side. Okay. Now, before the invention of calculators, mathematicians used to carry around tables that listed all these known ratios, depending on the angle, the ratio of this side to this side would be this, or if the angle was that, the ratio of that side to that side would be something else. Well, we don't have to carry around tables because those numbers are all programmed into our calculator. So all we have to do is know these three relationships, plug in what we know, and we can use our calculator to find what we don't know. So here we go. Now, after that long talk, let's try the problem. It says a girl is looking at a bird as shown. How high is the bird flying? Well, here we have a right triangle. See my right triangle up here? Okay, now notice that this is the angle they give me, a 20-degree angle. Now let's look at the side that we know as opposed to the side that we're looking for. Here's the side we know. See how it's connected to that 20-degree angle? This must be the adjacent side. Now the other one that we're looking at is this one across from the 20-degree angle. That's the opposite side. Okay, now that we know that the two sides that we have are adjacent and opposite, we know we should use the tan relationship because the tangent of theta is equal to opposite over adjacent. Write that down as your first step. Now, just like always, when we have a formula, we're going to plug in what we know. So one thing we know is the measurement of the angle. Our angle measures 20 degrees, so I will plug that in for theta. Again, theta is just like an x or an unknown, but we often use it when we want a missing degree, a missing number of degrees. Okay, now I don't know the opposite side. That's the x. That's this unknown that I don't know, so I'll plug in x for opposite. But I do know the adjacent side. The adjacent side here we said was 25 feet long. So there you go, I plugged in. Now this might look scary to you with that tangent of 20 degrees, but don't worry, that's the part your calculator does. The only thing you have to do as a mathematician is work to get the letter alone. So see how x is over here? He's currently got a 25 hanging out with him. Let's move the 25. Let's solve for x. So I'm going to do the opposite of dividing by 25. That's multiplying by 25. I hope you know, Ashley, that a fraction bar means the same as divide. So this literally said divide by 25. So I do the opposite. I multiply by 25. And the rule of algebra is you can do whatever you want as long as you do it to both sides. So I'm going to take this ugly, funky tangent of 20, even though it's weird looking, I'm still going to multiply it by 25. Now let's see what happens. Let's see what my new equation will be. On the right-hand side, multiplying and dividing by 25 are opposites, so my x is alone just like I wanted. And on the left-hand side, you might say, I don't know how to multiply 25 by tangent of 20. Don't worry, you don't have to. You just have to write it down. Oops, and already, look at me screwing up writing it down. I wrote 20 instead of 25, but here we go. 25 times tan 20 is 25 tangent 20. When mathematicians want to say two ugly things are multiplying, they just shove them up real tight. So we're almost done with this problem, but be careful. If you look, and I'm going to grab a different color so you can see what I mean. If you look at how this eagle is flying, this eagle is up here all the way from the ground to this high. That's the real height at which he's flying. But we only figured out part of that. We figured out this piece, the piece that was part of the triangle. And so what we're going to have to do to find the total height is we're going to have to add on this piece. You might say, I don't know how to add 5 to this funky thing over here. Yeah, no, just say plus 5, guys. You don't have to do the work. You just have to talk about the work. So I get 25 tan 20. To that, I would have to add an additional 5 feet. If I really wanted to simplify this, I would plug it into my calculator. Again, you do not do these ratios by hand. If back in the day before calculators, we carried around tables of values. Nowadays with calculators, they just have all those values programmed in there. So you would just type this entire thing into your calculator if you wanted to simplify it. But the particular problem that Ashley was working on, it wasn't simplified at all. So looking through your answers, they have it written like this: 25 tan of 20, same difference, plus 5. And that is a simplified expression. And And if you plugged it into your calculator, you'd get a decimal approximation. But this is a totally legit, even if it is scary, answer. All right. If you have any questions about this, or I guess any other HiSET math question, feel free to drop it in the comments and I'll do my best to answer it.